Hello and welcome to PreCalculus1. The blah was just the test, right? So we start the pre-calculus with study of functions because the functions are going to be the main focus of calculus later on. Calculus would lead to differential equations. Differential equations will lead into physics, engineering, economics, finance, and technically everything else. DFQ is where you actually start. In pre-calculus, you are going to study basic functions. We are going to cover polynomials. That's like your x squared, x cubed, and all that good stuff. We're going to cover rational functions. Those are the functions that have x's and fractions together. Then radical functions. Those are the ones with square roots, cube roots, and so on. We're going to cover exponential and logarithmic functions. And we call that PreCalc1. If you go to PreCalc2, that's going to be trig, which introduces 6 trigonometric and 6 inverse trigonometric functions. So additional 12 on the pile. All of those will be later on used in calculus, differential equations, and so on. So this course is a pre-calculus, right? Function is the central feature of our focus. And we start this course with the definition of the function, which will appear on your exam verbatim for 4 points. Okay? So I just told you exam 1 question for 4 points. Let's see who's going to miss it. Definition of a function. Function is a rule which assigns to each x in the domain a unique y in the range. Words to underline in this definition are rule, domain, range, and the word unique gets underlined twice. So when the exam question says, what is the definition of the function? Or what is a function? Or define a function? This is what you write. Now, I already mentioned at one point prior to starting the stream that the pre-calculus is not going to be monkey sees, monkey do, right? Like algebra. You will need to learn the concepts in order to apply it, because right now we are going to learn rules that apply to all of the functions. And if I give examples of 3 or 4 functions, I still didn't give you example for all 20 functions that you might cover in pre-calculus course, right? So learning the concept is important because you need to be able to apply the same concept to a lot of other functions and examples. I'll give the example of that as we go on. Now let's understand this definition and understand what the function is. So in mathematical language, we have these definitions which define terms. Our term that we want to define, obviously now, is a function. So what is a function as an object? Function, the word rule is related to equation or some kind of formula. So the word rule is formula or equation, so you know what you're computing. Domain is the set of all possible input variables. I'll explain these further. Range, set of all outputs, and the word unique makes the function. Okay, let's discuss this. I don't need to talk about the rule or equation. You all understand that you might have y equals 3x plus 7, and that's a rule, right? So that rule can change if I replace x with x squared or square root of x, or if I write everything divided by 3x and stuff like that. So the rule is just the equation itself. Now, domain are all of the numbers that you are allowed to plug in. This is why there is a word possible in it. There are certain rules, certain functions, where you are not allowed to use certain numbers. Otherwise, reality explodes. It sounds funny, but it's actually true. So, if I write y equals 6 over x, which number I am not allowed to use? 0. Why? Because you can't divide by 0. Now that's something that I will explain why, but not right now. If I have y equal 4 square root of 3x, I can't use any negative number here, because square root of a negative number is not a real number, it's an imaginary number. So there are restrictions. And also, there are examples, like I had y equal, let's say, 3x plus 2, examples where you can plug in anything you want, and it will always give you a real number. So we are going to learn how to figure out domain and range of functions, because in some cases you are not allowed to use certain variables. And range, set of all output values. Well, that's all of the y's that you can get when you plug in all of the x's that you are allowed to plug in. And now we get to the word unique. You notice that that word was underlined twice. So why is the word unique, and why did I say it makes a function? If you take that word out, what you get is a definition for something that is called mathematical relation. Function is a stronger concept. Functions are used to make things around us. Non-functions still exist, obviously, but let's talk about texting. Right? You want to text OK to a friend. That's just two letters, O and K. What do you have happening? When you push O, what happens? It prints O, right? And then you push K, and it prints K. And the reason why that happens is because the function that the texting follows is what you push is printed, and then you can send it. There is a one-to-one correspondence for you push O and O is printed. And it prints O uniquely every time. And if you give your phone to someone else to push O, O will still print. Because the function of the cell phone is to uniquely print the letter you pushed. Does that make sense? Now imagine if there was no function, if there was no uniqueness, right? You want to push O, and you push O, but that any of the 26 characters could print at random, right? Can you imagine the chaos of just trying to send OK? You push O, it prints R. You push to delete R, it prints number 2. You push to delete number 2, it prints letter D. You push, right? That would be crazy. That's what the uniqueness is for. Mathematical functions make sure that every time you push that button, the O prints. Every time you push K, K prints. The same like the light switch, right? When you walk into the empty classroom or the empty room and you flip that light switch, you don't worry about starting a stereo in your car or causing an earthquake somewhere, right? That light switch uniquely controls the lights that it's connected to. If you rewire the switch and give it a different function, then it will uniquely deal with that function. Do we see the connection between the math world and the what you call the real world? Because this is fake world, right? So the function is defined that there is a rule. The rule is I'm going to push a letter and the letter is going to print on a screen. That's a rule. The domain. Domain is 26 letters on the keyboard, plus 10 digits for numbers, plus punctuation and so on. Call it 50 keys, I don't care, right? But the idea is that I have certain number of keys that I can press, and that would be my domain. The output or the range is what I see on the screen and the message that has been sent to my friend to read, the OK. That's the output. You can also print the output. You can just show it on the screen. You can stream the output. You can send the text message, and that output has been sent. That's your range. Where does the answer go? What is the answer, right? And finally, the uniqueness prevents the chaos, right? Meaning that when you press R, you print R. When you press M, you print M, and so on. Now, in mathematics, because these are this is literally the infant stage of designing a cell phone, you have to understand the function so you can build up on it a couple of years of design, right? In mathematics, when I say the function is y equals 6 over x, and we say let x be 3, then we have y is equal 6 over 3 equals to 2. Uniqueness over here is that no matter who plugs in 3 and who divides 6 by 3, we're always going to get the 2. And it's 2 in France, it's 2 in China, it's 2 on the Mars, and outside of the galaxy. It's always 6 divided by 3 is 2. That's the uniqueness part. Similarly, if I have let x equals to 3, I will have y equals 4, 3 times 3, which is 4 times square root of 9, which is 4 times 3, which is 12. No matter who runs this calculation correctly, no matter who runs it, you always get 12. Always get 12. And that's the great part about this. One answer. Let x be 3 here. Y equals 3 times 3 plus 2. 9 plus 2 equals to 11. What you see here is the way to compute functions. When I or someone else provides you with the input value, which is x, you use that value to compute the y. And then you have the ordered pair, which you can eventually graph. Ordered pair 3, 2, because that's your x and y. Answer is your y value, because you have equal, right? And x is equal to 3, that's given. Over here is 3, 12. And over here is 3 and 11. These are ordered pairs that you can plot. You can find others and then connect them with a line. Notation. Oh, by the way, I didn't mention that whatever I write in blood, make sure you know, because that's going to be the most important stuff. Notation for the function is y equals f of x. F of x. That's not f times x. This is f stands for a function, and x represents the value that you're going to plug into that function to be computed. So that's our notation. And now I can replace all of these y's with f of x. So now I can write f of x is equal to 6 over x instead of y equals 6 over x. So all I did is I replaced y with the new notation f of x. Now you might protest, why? Y was just perfectly fine. No, it wasn't. Because what I can do with this notation now is I don't have to go to another line and tell you what to compute. I can just ask you, what is f of 3? See that notation? And you will say, oh, he replaced x with 3. Let me replace x with 3. That's 2. It's a little bit faster. And it gives you everything in one line. You know what your input is. You know what your output is, which are the parts of domain and range. And you also know what the rule with the calculation is. All in one line. You don't have to trace the rule separate from the input, separate from the calculation. Everything is in one. And that's why we have the notation it goes like this. It's very fast for me to switch now and say, what's f of negative 4? And you will say 6 divided by negative 4, because now my x is replaced with negative 4. That works out to be negative 3/2. I see my input again, see my output, so I have the point negative 4, negative 3/2 if I want to graph this thing. What's f of a heart?
Whatever heart's defined as.
It's a heart. Not broken. What happened?
X equals heart.
Yeah, x is heart. So what is the function?
6 over heart.
6 over heart. Good. Done deal. Awesome. You will say, what? Yeah, it can be a number, it can be an object. It could be a whole calculus expression if you want to. You can stick an integral over there. You are not learning an example. You are learning now that x gets replaced with whatever is your input. That's what you are learning right now. Because a little bit later, I think in 1.7 or 1.7 in this chapter, we are going to replace this x or a number or a heart. We're going to replace it with a completely new function. And we're going to call that function composition. So the sooner you understand and realize that we can plug anything and still compute, the better. So the function notation allows you to plug in values, right? Allows you to plug in values and compute those values if you have the numbers. If you don't have the numbers, then you just have the function, the rule. One function that you all probably have a PhD in by now is a linear function. You studied that in elementary algebra, you studied that in intermediate algebra, right? It was everywhere. If you ever took any of the physics classes, or even if you took microeconomics class, you had those, you had the linear lines there as well. You should be masters of y equal mx plus b by now, right? Linear line. So you are used to a linear line, y equals mx plus b. That same line in pre-calculus we can now call f of x equals mx plus b. And now we can just get some kind of example. Say f of x equals 1/2 x minus 2. Whatever. Now, I know that you know how to graph linear line by slope and y-intercept and all of that stuff, but let's pretend you don't, okay? Let's say you want to graph this the middle school way, which is you pick the points and then you connect the dots like in a coloring book, right? So what I'm going to do is I'm going to pick a couple of numbers, whatever numbers I want. So let's pick, someone shout out a number.
5.
I heard 5 first, then I heard 3, and I heard 6. Do we want more, or this is good enough? Good enough? Anyone wants a negative number, maybe?
-5.
-5 it is. So I have 1/2 of 5 minus 2. Half of 5 is 2.5. Minus 2 is very good, which is excellent. All right. Half of 3 is minus 2 is -1/2. Why did I put third? That's it. No. Half of 6 is minus 2 is, and half of -5 is very good. Minus 2. Excellent. What I got are 4 ordered pairs x, y, which I can graph and then connect them with a straight line. The first one is 5, 1/2. The next one is 3, -1/2. The next one is 6, 1. And the next one is -5, -4.5. -4.5 is -9/2. If we can flex, we should flex. Now, we are going to graph these points and connect them. This is the time where you use your square notebook for mathematics, right? Right. We have x-axis and the y-axis. It's always x-axis is the horizontal, y-axis is vertical. Doesn't matter which math course you take, all the way through differential equations, it's going to be like that. And we're going to count 5 on x-axis and then go half up, half of a square. You all see the squares, right, on the thingy? Good. 1, 2, 3, 4, 5, and then a half is half of the square right there. 3 and -1/2. 6 and 1. -5, -9/2, which is 4.5. So -5, 1, 2, 3, 4. That's -5. -4.5. -1, -2, -3, -4, -4.5. I hope you guys see that these points are collinear, meaning what?
all fall on the same line.
They're all sitting on the same line. Very good. There is the line, and you see that they all sit on the same line. So this is our way of, one of the ways of graphing. Now you say, hold on, I learned the proper graphing, right? In algebra, I know that I can go and use my y-intercept and count the slope. Yes, sure. What is the problem? 1/2 x minus 2? Your 1/2 is a slope, which is rise over run. And your -2 is the y-intercept. Do we all see a -2 y-intercept right where it should be? And then what do? We go 1 unit up, 2 units over. Right on the money. 1 unit up, 2 units over. It goes right through the 4, right? It has to fit. I mean, it's math. All right? So, if you don't know what the graph looks like, you can always do this. Pick your points, as long as they're in domain, as long as you're able to pick the points, and compute the y values. It creates the ordered pairs, which you can graph and connect them with the line. And this holds for every function that you will ever see. PreCalc1, PreCalc2, in Calculus 2 you learn hyperbolic functions. How many of you are actually going into Calculus 2 and Calculus 3, differential equations? So, yeah, some number. I know that whole bunch will stop actually at Calc 1, which is okay. If we have bio students, just make sure that the school you're going to is not requiring Calc 2, right? Because you should do it here in that case. Other than that, if your program where your transfer just requires Calc 1, then you're done. All right. Bio is tricky, school to school, different requirements. Now, graphically, going back to those concepts of a function, you can imagine domain as set of x values, whole bunch of them. You can label them x1, x2, x3, x4, x5. And then values in the range. y2, y3, y4. Range is the set of all y values. And now we do what we call mapping, where x1 goes here, let's say, x2 goes there, x3 goes here, and then x4 and x5, let's say, go to y4. The mapping, or this corresponding jump, right, from x to y, is done by the function. Another way to understand this is your x goes in the box and function changes it and spits out y. That's a block diagram for it. And that's literally what happens. If you recall our previous example, what did you do? You stuff in 5 into the machine, and machine spits out 1/2. So ultimately, what do the functions do? They change numbers. They change one number into another number using the rule that is assigned to you. Because you see that in the first line, 5 was changed to 1/2. 3 was changed to -1/2. 6 was changed to 1. Functions change numbers using the rule that is assigned whatever application is. And we are going to use that to compute a whole bunch of stuff. Now, we said that the word unique is very important, and the word unique is the one that makes the function. So in this case, I have that f of x1 gives me y1. F of x2 gives me y2. F of x3 gives me y3. F of x4 gives me y4. And f of x5 gives me y4 as well. Even though this happens here, uniqueness is still not violated. Okay? Because x4 will always give you y4 and x5 will always give you the y4. So the values that x4 and x5 are still unique to x4 and x5. Let's take a look at the bad case. Meaning not a function. Not a function is when single x value from the domain gives two different y values in the range. That's bad. No bueno, if you want to say it that way. So, do you see what's happening here? The x is producing two different y's. Let's assign a real world example to this. Do I have a volunteer? Just a name, that's all. Julia. Julia, you're going to be an x in this case. This one is going to be our classroom, and this one is your house. And here's the Julia over here. Do you see that you can't be in the classroom and in the house at the same time? Right? So that's not a function. It's not a function because you can't be in the classroom and at home at the same time. Now, with the wonders of technology, you can be sitting home and watching this and totally not be in a classroom, but you are physically not in the classroom, right? So you see that you have the case where single x value gives you two different y values, and that ruins uniqueness. I can go back to that texting example and say, Julia wants to press O to type OK, but on the other end, you might print an O, but you might print Z, right? And it's a 50-50 chance which one is going to come up, right? So function is when you push O, you get O. When you push K, you get K. In this case, if you push O, you can get O, but you can get something else as well. And that's not a function. So that would be the bad case in terms of when it's not a function. Now, do we have an example of this case? We do. It's called circle. If you consider circle on the xy coordinate plane with its equation which you learned the last class of your intermediate algebra class, x squared plus y squared is equal to, let's say, 9, if this circle is 3 units in radius. So you know that equation for a circle. That equation is not a function. Let me write that in blood. And it's not a function because if I am to pick any x value between -3 and 3, I will have two y values assigned to it. Pick a value between -3 and 3. 2. 2 is right here. I'm going to draw the line through 2, And do you see that there is a y value here and also the y value here? So the x value of 2 returned 2 different y values, and that's why it's not a function, because it ruins uniqueness. Uniqueness is ruined because x equals 2 can give me y equals root 5 or y equals negative square root of 5 if you compute this carefully, right? When you have x equals to 2, x squared is 2 squared, that's a 4. 9 minus 4 is 5. Square root of 5, you get the negative root 5, you get the positive root 5. Do you see that the answer for x equals 2 is not unique? It's 2 answers, right? Wait until you get to PreCalc 2 for the inverse sine and inverse cosine. You pick a number for x, it gives you infinitely many y values that are not unique. Those are not functions either. One thing that you must understand tonight is you are not learning PreCalculus1 as a unit for itself. You are learning PreCalculus1 that will be applied every single day for every next course you take on a daily basis. Every function you learn will share the same rules. And this rule, when something is not a function, operates plug in x. If it gives you multiple y's, it's not a function. If it gives you a single y, it's a function. And that's something that will stay with you every single math class you take past this one, including PreCalc 2, Calc 1, hyperbolic functions in Calc 2, and so on. Cool? I know, right? All right, so let's recap this and then go into the night. We start our semester by understanding the function itself. Function is the major player for PreCalc 1, PreCalc 2, Calc, and so on. Function is a rule which assigns to each x in a domain a unique y in a range. We explained what the important words mean. We see the way we plug in the value to calculate the output. Notation is f of x, and we said it was a good notation because we can see the input, we can see the output, and go through all of that stuff. Now, gave the example of the linear line because that's the function you guys know. It was never called the function before. Now I just call it the function. And we did the example where we graphed that function. One example that I wanted to ask you to graph is, let's say, x squared minus 1. You can write y equals x squared minus 1. You can write f of x equals x squared minus 1. So now, since you don't have the square paper, right, your graphs are going to be crooked and terrible, and we will be graphing till the end of this course. I would strongly suggest to hop to Target or Walmart or somewhere and just get a $2 or $3 graph notebook with a spiral, right? So that you can do the graphs precisely, because you will be learning from graphs as much as you will be learning from these equations and so on. The issue with the lined paper is that it doesn't give you the horizontal divisions, only the vertical ones, because it's just ruled with horizontal lines. And you are not going to have the correct spacing. You won't be able to read values very well from the graph and all of these kind of things. So if you have a square paper, you will have the advantage to learn graphing quickly. I don't want to do this problem because I want to leave it as a challenge, or the first thing you do if you get the paper over the break, because 5 days till next class, so you can call it a break. You will pick values for x. Let's say -2, -1, 0, 1, and 2, 5 values. And then you will compute f of -2. You plug in -2, f of -1, f of 0, and so on. That will give you y values. You will have ordered pairs. You plug those and you connect them. We will spend the entire chapter 2 next month working with what we call polynomial functions, which will include linear line, quadratic, cubic, and all of that stuff. Right now, we don't care about their names. All we care about is the skill that you can pick a number, plug it in, come up with y. We also are interested in learning that if you write f of x or you write y, it means the same thing. Okay, because f of x is y. So that's new in notation for you guys. And you know that you are plugging the values here, which immediately the same number replaces this x, because if I replace this x with a heart, I replace that x with a same heart. And then we do the calculation, or a number, or another function, or so on. I don't have closing for any of these, so I just shut it off.